An object near the surface of the Earth is subject to gravitational force that produces a downward acceleration denoted by the gravity g. For motion close to the ground, we may assume that g is constant, its value being about 9.8 meters per second squared, or 32 feet per second squared. In example 6, a ball is thrown upward with a speed of 48 feet per second from the edge of a cliff 432 feet above the ground. Find its height above the ground t seconds later. When does it reach its maximum height, and when does it hit the ground? So, since we're dealing with gravity here, okay, we should know that the acceleration function is the following. It's going to be constant. So the acceleration function, okay, is going to equal negative 32, since that is what we're dealing with in gravity. And again, the units are feet per second squared, so that tells us that it's acceleration. Okay, now if we want to find now the velocity function, we're going to take the antiderivative of this acceleration function. So v of t is going to equal negative 32t plus the constant c. Okay, so now we need to look at the fact that this says that the ball is thrown upward with a speed of 48 feet per second. Well, that 48 feet per second is in terms of velocity. So what that tells us is that v of 0 is going to equal 48. And so that's going to allow us to find out what is the constant c. So let's go ahead and plug that in. We know that v of t is going to equal 48, and we know the value of t is going to be 0. So therefore, we know c is going to equal 48. So the velocity function v of t is going to equal negative 32t plus 48. Okay, so now what we want to do is now we want to be able to find the position function. So what we want to do is we want to find the antiderivative of the velocity function. So to find the antiderivative of the velocity function, it's going to be s of t. So this is going to be negative 32 to the 1 plus 1, which is 2, over that 2, plus 48t, and then we're going to call our constant here d. Okay, so let's simplify that a little further. So s of t is going to equal negative 16t squared plus 48t plus d. Okay, so now what we need to do is we want to be able to find out what is the constant for d. Well, recall here that it says that it's from the edge of a cliff, which is 432 feet above ground. So that means the position function of when the time is 0, that means it's going to be 432 feet above the ground. So now we can figure out what d is. So we know that s of t is going to be 432, and then we're going to plug in 0 in for the value of t. That gives us 0, and so now we know that d is going to equal 432. So therefore, our position function s of t is going to equal negative 16t squared plus 48t plus 432. Okay, so now that we have this information, I'm going to move us over just a little bit. Okay, and so now what we want to do is we want to find out, okay, find its height above the ground t seconds later. Okay, so, and then when does it reach its maximum height? And when does it hit the ground? Okay, so let's go to step number 4 here. So, when does it reach its maximum height? Well, in order for it to reach its maximum height, we need to let the velocity function, v of t, equal 0, and then solve for the value of t. Well, what is v of t? We know that it's negative 32t plus 48, and we set that equal to 0. So therefore, solving for t, we get negative 32t, which is equal to negative 48. Divide both sides by negative 32, and simplify, and we get 1.5. That's 1.5 seconds. So at t, which is equal to 1.5 seconds, is the maximum height. Okay. All right, next. Now we want to figure out, when does it hit the ground? Well, it's going to hit the ground when? Well, when the position function, s of t, is going to equal 0. So what is the position function? Well, we know that's negative 16t squared plus 48t plus 432, which is equal to 0. Okay, so the first thing that we can do is, since this is a factor, everything is a factor of negative 16, we can divide everything by negative 16. So what we end up getting is t squared minus 3t minus 27, and that's equal to 0. Okay. Now we can't factor this cleanly, so we're going to have to use the quadratic formula. So the quadratic formula tells us is that we can find t to equal a negative b, and that's plus or minus the square root of b squared, which is negative 3 squared, minus 4 times the value of a times the value of c, which is negative 27, over the value of 2 times a, which is 1. So we end up getting t, which is equal to 3 plus or minus the square root of 9 plus 108 over 2. So we're going to get t, which is equal to 3 plus or minus the square root of 117 over 2. So that's going to give us two values. We're going to have two values here. We have 3 minus the square root of 117 over 2. And then we have 3 plus the square root of 117 over 2. We plug this into our calculator. We get approximately negative 3.9 seconds here. And then we get approximately 6.9 seconds here. Well, we know that we're not going to have a negative time. So that means we're going to have to eliminate this. And so what that tells us is that the ball will hit the ground, or the ball hits the ground at t, which is equal to 6.9 seconds. Now let's take a look at a visual of this. Okay, so this is what this figure would look like. So it shows the position function of the ball in this example. The graph corroborates the conclusions we reached. The ball reaches its maximum height after and hits the ground after 6.9 seconds. So there's approximately 6.9 seconds, and therefore you can see what the graph looks like.